Known by the public as drones and within the military as remotely piloted aircraft, UAVs or unmanned aerial vehicles are a rapidly growing presence in 21st century airspace. The safe operation of UAVs alongside civilian aircraft in national and international airspace is a major DoD objective which supports civil authority missions, U.S. combatant commanders, and the overall readiness of our military forces both stateside and abroad. The main risk to safely flying military UAVs in shared airspace is their off-board pilots lack the ability to see, avoid, and remain well clear of other aircraft. Specifically, UAVs must be able to maintain self-separation and avoid collisions. Through the efforts of the Air Force, federally funded research organizations, and industry partners, it is now possible to equip UAVs with technology that satisfies the sense and avoid safety standards required to obtain FAA authorization to fly in national airspace. This new capability, referred to as the Common Airborne Sense and Avoid System, or C-Absaa, will pave the way to achieving safe, integrated flight of UAVs in national and international airspace. The C-Absaa vision is to provide an integrated, platform-agnostic solution to the sense and avoid problem. By leveraging multi-sensor technology, real-time data fusion, other aircraft track management, and optimized avoidance maneuvers, C-Absaa will allow UAVs to fly safely in proximity with other aircraft across a broad spectrum of airspace classes and operating environments. C-Absaa addresses both cooperative and non-cooperative aircraft integration. Cooperative aircraft are defined as aircraft that have an electronic means of identification, i.e. a transponder aboard and operating, and may include Traffic Alert and Collision Avoidance System, or TCAS, and Automatic Dependent Surveillance Broadcast System, or ADSB. Non-cooperative aircraft, such as privately owned civilian airplanes, are those that do not have an electronic means of identification, i.e. a transponder aboard, or not operating such equipment due to malfunction or deliberate action. Because the UAV pilot is an integral component of flight safety, C-Absaa is also focused on developing new display methodologies for a variety of UAV ground stations, enhancing pilot situational awareness and their ability to maintain safe control. Since every military UAV platform is unique, C-Absaa must also be modular and adaptable to fit on board a variety of UAVs with different size, weight, and power limits. C-Absaa is currently focused on supporting Group 4 and 5 and being scalable to Group 3 military UAVs. The C-Absaa system concept is to provide UAVs with a see and avoid capability similar to that of manned aircraft, which will allow UAVs normalized access to non-segregated airspace worldwide. By combining inputs from ADSB and TCAS cooperative systems aboard other aircraft and inputs from electro-optical and radar-based sensors aboard the host UAV, C-Absaa generates a real-time 3D picture of the surrounding airspace. The onboard C-Absaa computer continuously evaluates this airspace picture for potential collisions, and if a dangerous situation develops, recommends maneuvers to the pilot to remain well clear of other traffic and will automatically execute a collision avoidance maneuver should this final level of safety be required. Developed by the Air Force Research Laboratory, the C-Absaa computer is known as MUSICA, short for Multi-Sensor Integrated Collision Avoidance. MUSICA integrates the multiple sensor inputs to track nearby aircraft, evaluate potential collision threats, and calculate optimal collision avoidance maneuvers. As military usage of UAVs continues to expand, sense and avoid technology will become crucial to decreasing coordination requirements, thereby increasing mission flexibility. Defense Research Associates has developed and flight tested a passive electro-optical sensor with relatively low size, weight, and power requirements, making it adaptable to smaller unmanned aircraft. Colorado Engineering Incorporated is developing the U-STAR, or Unmanned Sense, Track, and Avoid Radar, based on a high-fidelity pulsed Doppler design. The Air Force, via Northrop Grumman and Burl Applied Research, is improving the portion of the MUSICA algorithm that computes the optimal path for collision avoidance maneuvers in real time. The Air Force is funding a series of Northrop Grumman flight demonstrations for an automated sense and avoid system that is modular, scalable, and adaptable to various UAVs. In an effort to accelerate UAV integration into the national airspace, the Air Force is working directly with the FAA through the RTCA Special Committee 228 and the Aviation Rulemaking Committee to develop standards and policy for UAV integration into the national airspace, while the Air Force is also developing an incremental acquisition program focused on developing effective, cost-efficient technology. C-Absaa will be a critical component in the safe operation of Air Force UAVs, enabling them to fly, fight, and win over the next half-century.